Dear friends, Namaskar. Myself S.K. Rajput. Today we will learn the topic chemical reactions and equations from chapter number 1, class 10th, science. Listen. First of all, chemical reactions and their types. Chemical reaction means there is formation and breaking down of bonds between compounds. So different types of reactions are types. We can remember reactions by district C, D, 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 R. The C stands for combination reactions. D means displacement reactions. This D is double displacement reaction. This D is decomposition reaction, and last is redox reaction. So in chemistry, the main 5 types reactions are these types: combination. The opposite of combination is decomposition. Displacement, single displacement, double displacement, and redox. So one by one. First, combination reaction. In combination reaction, 2 or more than 2 reactants will combine and give a single product. Single product formed by mixing 2 or more than 2 reactants. These are reactants, this is the product. Suppose, very simple. Suppose carbon is reacting with oxygen and forming CO2. Here carbon and oxygen, 2 reactant. After the reaction they are giving single product CO2 along with heat. So this type combination is called exothermic reaction. Exo means removal, thermic means heat. So in this reaction heat is removal, so this is called exothermic reaction, but category is combination reaction. Suppose second example, if carbon is reacting with sulfur, carbon is solid, so we write simple, but oxygen is gas, we write 2. Generally gases are written in a diatomic form. This is sulfur also solid. So again similar CO2, CH2 is formed. So here I am writing 2 for balancing the reaction. CH2 is formed. Here 1 carbon, 2 sulfur reacting and give a single product. This is also combination. But in this reaction, heat is absorbed. So if in any reaction heat is absorbing, this is called endothermic reaction. Endo means absorbing and thermic means heat. So on the basis of heat release or absorbing, reactions are 2 types: exothermic and endothermic. Another best example, good example is when CaO, this is calcium oxide. If calcium oxide react with water, otherwise calcium oxide react with CO2. Calcium oxide, this is also called quicklime. Quicklime, when we dissolve water, it gives CaOH whole 2 along with heat. This is exothermic, and this compound is called slag lime. Listen, in this reaction calcium oxide means quicklime is the one reactant, it is another reactant. These 2 reactants are combining and giving a single product, that is calcium hydroxide, also called slag lime. When calcium oxide means quicklime absorbs CO2, it forms CaCO3. CaCO3 is called limestone. So this is also called combination reaction. So these are 4 different examples of combination reaction. What you observe? That in combination reaction, simple, 2 or more than 2 reactants, these reactants fuse and give a single product. And we already discussed the opposite of combination reaction is called decomposition reaction. Decomposition means breaking down. Suppose, listen. Second, here we are discussing about decomposition reaction. Decomposition reaction is just opposite of combination reaction. What you observe in combination reaction? In combination reaction, reactant combine and giving single product. Here, single product, suppose this is calcium carbonate. If we provide heat, this calcium carbonate breaks down into calcium oxide and carbon dioxide. Here reactant is single, but after heating products are two. So this is called decomposition reaction. Example number 1. Example, suppose another compound. This is FeSO4. FeSO4 is ferrous sulfate. Ferrous sulfate. On heating ferrous sulfate, it gives these three compounds. Fe2O3, the valency of iron is 3, the valency of oxygen is 2. So we write crisscross pattern along with two gases, SO2 and SO3. So for balancing, iron is 2, I am writing here 2. So all are balanced. So in this reaction, FeSO4, it is a reactant, it is decomposing into these three different compounds. In exam, they ask that there is the green color compound. After heating, this green color compound decompose into three different products. First is solid, that is brown in color, and remaining two are gases of same element. Here these are two gases, and these gases are formed by sulfur, sulfur dioxide, sulfur trioxide. These two gases have pungent smell, and also their smell is just like burning of sulfur, burning of sulfur. Third, this is lead and this is nitrate. The valency of lead is 2, so we write in here 2. The valency of nitrate is 1, so we write here 1. So this is lead nitrate. On heating lead nitrate, this also gives different types, 3 products. Oxide of lead, this is PbO. Valency of Pb2, valency of oxygen 2, crisscross PbO. And one important gas NO2 along with O2. For balancing the reaction, here you observe Pb is single, this is 2, but for balancing oxygen, I am writing here 2, here 2, here total nitrogen become 2 to 4, so I am writing here 4. Observe, in exam they ask, there is white color compound, this is solid. On heating white color compound, it gives 3 different compounds. The black color lead oxide and a brown colored gas, this is brown color gas, and a gas which help in combustion. In first reaction, in exam they ask that there is the solid, white color solid. On heating it gives 2 compounds. First is solid and another is gas. This gas glow of the fire, and also this gas turn milky color to lime water. If we pass CO2 gas in lime water, the color of lime water become milky. So after the reaction, you remember what are the different properties of these gases. Property of O2 gas, help in combustion. This is brown color gas. These two are gas of same element with pungent smell, also in smell, just like burning of sulfur. This is carbon dioxide. It used to glow of fire, and also it turn lime water milky. So observe, in all these 3 reactions, single product is decomposing and it gives different types product. Product are more than 1, but all these 3 reactions, what one thing is common? One thing is that in all these 3 reactions we are providing heat. So all these 3 reactions are called thermal decomposition. So decomposition is breaking down. Suppose this is pen, I want to break down this pen, so I should be applying energy on this. Energy may be by any source, by heat, this is thermal. The energy we can also apply by sunlight. Suppose this is AgCl. AgCl is silver chloride. If we put silver chloride is white color compound. Sorry. If we put silver chloride in sunlight, it decomposes into 2 parts, Ag along with Cl. Cl is gas, we writing here 2. So for balancing reaction, I am writing here 2, this is 2. This gas release and silver is remaining. silver, the color of silver is green. So this reaction is used for black and white photography. Instead of AgCl, you can also use AgBr. So in this reaction, sunlight is the source of energy for decomposing the compound. This type decomposition reaction is called photo decomposition reaction. So decomposition takes place by thermal, means heat, otherwise by sunlight. This is second category of. And one more thing, suppose this is water molecule. If we are passing electricity, so process is called electrolysis. By passing current in water decompose into two gases, these two gases. For balancing the reaction, I am writing here oxygen 2, hydrogen 2. So these two gases liberate. This is water. Water is a reactant, and water is decomposing into hydrogen and oxygen. But we are providing electricity. So this is called electric decomposition. Means third, electric decomposition. So decomposition takes place by help of different three source of energies. First, heat. If we are providing heat of any compound, this is called thermal. Second, sunlight. This is called photo decomposition. And also third, electricity. So this is called electric thermal decomposition. In last lecture, generally they ask that which gas liberate on which electrode if we pass current in water. Observe and remember, this hydrogen liberate on cathode, this liberate on anode. Suppose these are two electrodes, we are dipping in water and passing current. The hydrogen gas liberate on cathode and oxygen gas liberate on anode. How can you remember? Simple. In hydrogen there is H, in cathode there is also H. These H letter is common in these two. So remember, at cathode hydrogen gas liberate during the what? Passing current in water, during the electrolysis of water. So quickly revise decomposition. Decomposition reaction is just opposite of combination. Decomposition reaction may be by heat. Heat means thermal decomposition. In thermal decomposition, we are providing heat to limestone, ferrous sulfate and lead nitrate. Second is photo decomposition and third one is electrolysis. The reaction third D, we have written what? CDDDDDR. First is combination. Suppose second is decomposition, third is displacement. Displacement reaction. In displacement reaction, suppose this is H2SO4 and this is zinc. Remember, zinc is highly reactive than hydrogen. So highly reactive element can replace less reactive element from its compound. This is compound and zinc is highly reactive. After the reaction, zinc sulfate will form along with removal of H2 gas. Listen, this H2 gas burn with pop sound. So in exam they ask that there is the compound, metal replace and form a compound with liberating a gas. This gas burn with pop sound. Identify the gas. Gas is H2 gas. This gas also used in a fuel. What is the concept? Concept is that highly reactive metal replace metal other element, highly reactive element replace to least reactive element from its compound. Suppose FeSO4, we are reacting FeSO4 with copper and zinc. Do you know? Which out of these three, zinc, iron and copper, out of these three, which element is higher reactive, then lesser? These properties depend on activity series. In next video we will discuss what is activity series and how can we remember the activity series. Listen, in these, this is least reactive, this is more reactive, this is higher reactive. So zinc can replace to iron, but copper does not. Zinc replace and will form zinc sulfate along with iron. Here no reaction. If you are taking opposite, means copper sulfate with iron, iron is highly reactive, it takes place. In this reaction, one element is replacing another element from its compound, otherwise salt. After the reaction, FeSO4 along with copper is formed. So in exam they ask, copper sulfate is blue in color, this is black, and after the reaction FeSO4, the color of FeSO4 is green and its color is brown. So after reaction, iron replaced to copper, and on the surface of iron the brown color copper deposit, and color of solution change from blue to green due to formation of FeSO4. And in this reaction they ask, zinc is highly reactive, so zinc is used in the method is called galvanization. Due to meaning of galvanization, galvanization is the process in which around the metal of iron we form a thin layer of zinc, because zinc is highly reactive than iron. So zinc by sacrification corrode and protect iron. This process means if we want to protect iron from corrosion, we form a layer around the iron surface of zinc metal. Process is called galvanization due to higher reactivity of zinc than iron. Okay. So this is displacement reaction. In displacement reaction, what we observe? One element replace another element from its salt. Which element replace? Higher reactive element replace to least reactive element. Now fourth is double displacement reaction. In double displacement reaction, suppose observe here, these are two compounds. In double displacement reaction, we use two compounds. In two compound, this is ion, this is also ion. So we exchange these two ions from here to here. You can observe there are two pens, and we are exchanging the ions of these two compounds. Observe. Suppose, listen, this is silver nitrate. This is salt. It has silver plus, nitrate minus. Another. This is sodium chloride. This is plus and this is minus. If we dissolve, AQ means aqueous solution. We dissolve these two compounds in each other. Then what will happen? After the mixing, sodium is highly reactive. It replaces to silver and silver replaces to sodium. After reaction, what will form? AgCl along with sodium nitrate. AgCl and sodium nitrate. AgCl. Observe. So how can we define that? In double displacement reaction, two salts are using, and between these two salts, ions exchange. Silver and sodium, these are ions and these exchange in a product. Before reaction, silver nitrate. After the reaction, as a product, silver chloride is formed. Look and remember, silver chloride is white color compound. This white color compound is insoluble in water. So it forms precipitate. I am writing PPT. PPT means precipitate. It precipitate and settle down. We can filter and dry this compound. So this reaction in which after reacting two compound, product form in the form of precipitate. Reaction is called precipitation reaction. Precipitation reaction means in which one product form as a precipitate, solid and settle down. Work for you. AgCl, filter and dry. and put this AgCl in sunlight. What will happen? Simple. AgCl will decompose in sunlight, will give Ag and Cl. Ag form grey color. So this is called photodecomposition reaction. But this is called double displacement reaction. Another most important double displacement reaction, suppose this is sodium sulfate and this is barium chloride. The valency of sodium is 1, the valency of sulfate is 2. So I am writing here 2. And the valency of barium is 2. I am writing here 2. So when barium chloride react with sodium sulfate, we are dissolving these two in aqueous solution. Then barium replaced to sodium and sodium is replaced by barium. What will form after the reaction? Barium sulfate along with sodium chloride. Barium sulfate, sodium chloride, 2. This barium sulfate is also white color precipitate. So this is called double displacement reaction along with precipitation reaction. In precipitation reaction, product form in precipitate. We can filter, we can dry the compound. The last one is R. R stands for what? R stands for redox reaction. Redox. We have written the trick CDDDDR means combination, decomposition, displacement, double displacement, and this last R means redox reaction. Redox reaction is the combination of red plus ox. So red means reduction and ox means oxidation. So what is the meaning of reduction and oxidation? In simple and general language, we can say reduction means reaction of hydrogen, addition of hydrogen, and oxidation, addition of oxygen in simple term. But in chemistry, in electronic definition, we say that reduction means reducing the oxidation state. If any element, suppose this is Cu2 plus, this is gaining of electron forming Cu0. So here copper means cupric 2 plus, it is gaining 2 minus and forming 0. So here the oxidation state means valency of this copper is reducing, it is decreasing. So process is called reduction. Remember, reduction. And this ion of which reduction takes place, this is called oxidant. Otherwise we can say oxidizing agent. Oxidizing agent or oxidant means the species of which reduction takes place. Here oxidation means, in electron definition, oxidation means increasement of valency. Suppose this is zinc. After the reaction, zinc form Zn2 plus along with removal of 2 electrons from zinc. Zinc is 0 means its oxidation as a product reactant is 0. After that it remove 2 electron from 2 plus means valency means oxidation state of zinc is increased from 0 to 2 plus. Process is called oxidation. But this species of which oxidation takes place, this is called reductant, also called reducing agent. So reducing agent, reductant means the species of which oxidation state means power means charge is increasing in any reaction. Suppose here, observe. Suppose this is copper, the valency of copper is 0. It is heating in presence of air. From air it absorb oxygen and form CuO. Can you find out the oxidation of these two reactions? Copper becomes Cu2 plus from 0 to 2 plus. In this case, the valency of copper is increasing. This process is called oxidation. In both, addition of oxygen, otherwise you can say oxidation state of copper is increasing. But here copper is called what? Copper is called reductant because its oxidation state is increasing. In exam they ask, there is the metal of which color is brown. If this metal is heated in air, it forms black color. The color black due to formation of copper oxide on the surface of copper. So for balancing we can write here 2, here 2. If we pass hydrogen gas on the surface of this black color cupric oxide, it absorbs oxygen, N for water, N copper remain same. So what happened in this reaction? In this reaction, hydrogen is adding. So reaction is called reduction. In electron definition, you can say the valency of copper is decreasing from G plus 2, it becomes 0. So in this reaction, CeO, this is the compound. In this compound, the valency of copper is reducing. Process is called reduction, and CeO is called oxidant. Simple definition. So we can define redox in simple language. Redox is the combination reaction of reduction and oxidation. Reduction means reducing. The oxidation state is decreasing. But oxidation means oxidation state is increasing. Other you can say adding of oxygen, adding of hydrogen. But in some time in other reactions, adding of oxygen and adding of hydrogen does not appear. In only electrons exchange you should be noticed. Suppose example, sodium and chlorine, these are two reacting and forming NaCl. This is redox reaction. How can you say? In this reaction, the valency of sodium is increasing from 0 to plus, but the valency means oxygen state of chlorine is reducing. It is from 0 to minus 1. So if oxygen state increasing, oxidation takes place. Oxygen state is reducing, reduction takes place. Simple. Okay. Thank you for watching. Namaskar. Stay safe and